I will be discussing what mainly regulations are going to lead us to do in terms of MLOps tools if we want to really make developers' lives easier. There are 7 key principles to the GDPR. The GDPR is the one I bring up first because it is the one that has been affecting the world the most. It applies to every EU citizen around the world, regardless of where they are located. And a few things that are really core that you might be used to seeing as people in machine learning is the word fairness. But also, what you really need to keep in mind with the data that you're using is purpose limitation. With purpose limitation, that's really limiting what you could use the data for. You need to get positive consent from users in order to use the data for specific tasks. Also, data minimization. Thank you. You only get to use the data that you actually need for the task at hand. You can't just collect willy-nilly a bunch of personal data. And another one is storage limitation. So you do have to have a set amount of time during which you can store the data, and afterwards, if you don't need it anymore, you do have to delete it. Then there's accountability, integrity, and confidentiality. But really, there are these core components that you mostly need to pay attention to when you're dealing with machine learning data. The positive consent aspect of it, did you get the right consent from your users to use it for that application? The data minimization, as I mentioned. The tracking the location and the uses of the personal data, so where are the personal data stored? And you also have to be able to perform access to information requests and rights to be forgotten. So if somebody wants to know what kind of data you have on them or want that data to be deleted, that's where tracking the location of the personal data comes in handy. And this is a lot of text, but this is especially important to get the definitions right when it comes to what is personal data. Personal data is information that can re-identify an individual. And that includes direct identifiers as well as quasi-identifiers. Direct identifiers like names, full names, like exact locations, to a certain extent social security numbers. Those aren't unique identifiers, but can still identify a small portion of the population to which they can be applied to. And credit card numbers, unique identifier. And then there are quasi-identifiers where when you add them together, it increases the risk of identifying an individual exponentially. So things like origin, sexual orientation, religion. And this is all information that you need to be able to keep track of or remove as quickly as possible. You may have also heard the word pseudonymization. Under the GDPR, pseudonymization means that you're linking a certain replacement of a piece of personally identifiable information in a database with the original data. So it might be better known as tokenization for a lot of you. And personal data can only be considered anonymous if you've actually removed the risk of re-identifying an individual. That I could get into. It's a very tricky process of what kind of guarantees can you actually make. The GDPR doesn't actually tell you what the threshold is of re-identification. And a lot of regulations don't actually tell you how to actually properly anonymize data. And if you are pseudonymizing data rather than anonymizing data, you still need to be compliant with the GDPR. So you still need to keep track of where that data are stored and treat it like personal data. And this is an interesting part. Just fun fact, doesn't necessarily apply to you, but this also applies to data that's on paper, not just electronic data. So something to keep in mind, but not for MLOps. Where we see that the regulations might be going, because a lot of these regulations for data protection have mainly relied on fines. These fines have not been that effective at stopping large organizations from misusing the data, or even smaller organizations. Though we are getting to a place where people are starting to take it more seriously. In some organizations, They have made the entire world organization comply with the GDPR, but there's still these several stragglers behind. One proposal that's put forward is actually making people delete the algorithms that are not compliant with things like the GDPR or other data protection regulations. So that is a much stricter and much more effective way of getting people to comply, because that's a whole line of business that can go away. So this is another reason why MLOps platforms really need to take this into consideration because it's such a complex task that needs to be built into what the workflow is that machine learning engineers are going through. In this case, Clearview AI was ordered by the UK to delete data belonging by the residents of the UK. But if you've been following this case, Clearview declined to do so because they don't operate in the UK, and we'll see where this goes. The FTC also is considering enforcing companies to destroy algorithms. And one such case is for Weight Watchers. And Weight Watchers was collecting children's data without their parents' consent. And the FTC has required them to delete those algorithms that were trained with that processed the children's data. Another regulation to keep track of is the draft EU AI regulation, and it separates the uses of AI systems into 3 categories. Unacceptable risk AI systems, such as social scoring, any sort of surveillance in public spaces by the authorities. High-risk AI systems, for example, you might think of insurance, processing claims using AI or determining whether somebody is a candidate for insurance. And then questionably limited and minimal risk AI systems like chatbots. And here you see something that's very similar to what is required of people from the GDPR. You need to be able to assess the impact of the algorithms, but also that requires keeping track of the personal data, right? But it goes one step further. These impact assessments also require an analysis of bias and fairness and explainability. And it also requires people to make sure that the systems are secure. So what's missing in MLOps systems? We do have a certain amount of model governance. That's the core of MLOps systems. Robustness, actually, I should have pointed that out, but there is quite a bit of work in robustness for models in MLOps systems, but not necessarily for robustness against cybersecurity or against malicious attacks. There is some work starting. TrojanAI is a company that's doing some really interesting work in that space, for example. But fairness, explainability, there has been work in that space as well. I'll touch upon a little bit of that work. But data privacy really is the crux of what a lot of these regulations require. So that's where I'm going to dive deepest in. For responsible AI tools to be in MLOps, they need to be able to process large data sets. They need to be part of a repeatable pipeline. There needs to be a linkage with a company's privacy policies, for example, in order to really make sure that no policy is being broken. And these systems also should provide an array of options to their users in terms of what kind of privacy technologies they can use to protect their data, or what kind of fairness and bias technologies they could use. There are some really interesting tools out there. One thing I recommend you take a look at is Ethica Fetus Ops, and they are doing privacy ops, and they're open source, and allows you to basically build a CI/CD system within your software development environment. They fit into IDEs as well, so that you can keep track of where your personal data is going and how it interacts with your privacy policies as well. And it basically creates a little packet of metadata that follows the data that you're using around. There are also TF fairness indicators, TF language interpretability toolkit, and you can integrate this into your TensorFlow pipeline. The language interpretability toolkit is really interesting. It allows you to see what kind of inferences are being made on specific pieces of text, and that can help you detect whether there's any particular kind of bias, for example. There's explainability that you could do using Arthur AI. That one, I believe, is a private company, not open source. But then there's an open source tool called Selden.io, which can help you with explainability, interpretability, and drift detection. And an integration within MLOps pipelines of several of these tools would be really incredible for being able to satisfy these regulatory requirements that are in place and coming up. Now let's focus on privacy. If we look at this graph that I took from NVIDIA of what an MLOps pipeline looks like, really where you might care about privacy is at the data collection point, and at the model training point, and at the deployment point. The data ingestion point can be where you process the data in a way that makes it privacy preserving. The model training point might be where you process it using differentially private gradient descent, if you didn't already do something at the data ingestion point. And the ML systems deployment part can be about creating federated learning systems, for example. And I'll get into the nitty-gritty of some of those. There are 4 pillars of privacy-preserving AI that you need to keep track of. There's training data privacy. So can anything be identified about the training data that from the personal information that was in there, from the users that you may have collected data for that purpose. So I'll get into some examples of where that has gone wrong. There's input data privacy and output privacy. Those are very much also user privacy problems, so really keeping track of what kind of data can your system see, what kind of data are you allowed to store and to process in your environment. And model weights privacy can be in part to preserve training data privacy, but it is very much also to protect the corporations who have built the models, and these are their bread and butter. Some of the privacy concerns to keep track of are identity disclosure concerns. So can you re-identify an individual? And that's really where most of the data protection regulations actually come in. They don't really look at group attribute disclosure or attribute disclosure where the question there is, can you attribute some sort of feature or outcome to a particular individual? So, for example, from the data that you collected, can you determine that a person of a particular category has cancer? And then membership disclosure. Do you know whether a particular individual was part of a pharmaceutical study, for instance? And this particular sloppy mess from Scatter Lab, which is a Korean company that created this chatbot that they were boasting about having billions of conversations between users from, really caused an identity and attribute disclosure problem as well as a membership disclosure problem. So they had created this lovebot, and next thing they knew, in production, that lovebot was spewing out entire names, entire addresses, and other personally identifiable information. And this is something that has been seen in research quite a bit. So there's this really interesting work called The Secret Sharer by Carlini et al. And in it, they hide a sequence of numbers, random numbers, in the Penn tree bank database. And they teach a character language model with this data. And they calculate the perplexity and find that the model is actually less surprised at seeing the numbers that were in the data, that were hidden in the database than other random numbers. What that means is that the model memorized the numbers, and it's hiding that information within the model weights. So that is a huge problem. They also showed later on that GPT-2 was memorizing personally identifiable information from the training set. And they showed that this included entire addresses, for example. And why this is important is that we do not have the consent of the people from these web scrapes to use their data for this particular task. And if you care about the GDPR, you don't know if these people are EU citizens, for example. And then this other work by Mohammed Abdallah et al. From the University of Toronto showed that even word embeddings can memorize information about other words that were close to them. So you have to be careful when training, for example, word embeddings that are specific to healthcare, because somebody's name might be closer in distance to the disease that they were mentioned with, or somebody's first name might be closer in distance to their last name. And that can be quite problematic. So what are the solutions? You can have differential privacy, which originally was meant to make it so that you could generalize over structured databases, right? So you could be looking at a database that has somebody with a very rare disease, and you don't want, and also information about who has cancer and who smokes. And you want to be able to make generalizations that people who smoke get cancer, but you don't want to be able to know that Joe is part of the data set and has this rare disease. So it's about adding a little bit of noise to the output. And this little bit of noise that gets added to the output makes it very difficult to tell whether maybe there was one person or two people or no people in the database that had a rare disease if you are sneaky with your queries. Then in Carlini's work, The Secret Share, they proposed this other definition of differential privacy, where it applies to algorithms. So basically, if you have two data sets that are almost identical except for one bit of data that's modified, you expect the algorithm that you train on these data sets to have pretty much the same outcome minus a small amount of probability that they won't. And usually the way that you do this in machine learning is to do gradient clipping and add differentially private noise to the gradient. So no particular individual rare piece of information is throwing off the gradient and therefore making the model memorize that sensitive data. Now, there is, as I'm sure you know, a risk between the disclosure risk and the utility risk when you're using differential privacy. The pro is that differential privacy does provide mathematical guarantees of a worst case scenario. However, the higher the guarantee, the lower the accuracy. And one thing that's particularly interesting to note is that for underrepresented groups, a lot of the times they have rare data as well. So them having rare data means that their data does not get represented in the model if you're using differential privacy. What this means in MLOps is if you're considering bias, if you're considering explainability, these are all things that you need to take into account. How do these play together? Very good research question. Another solution is redaction or de-identification. So removing names, locations, personally identifiable numbers, quasi-identifiers like religion, and then you get a piece of text that your machine learning model is not going to be able to memorize the private information of because it's just not there. And you could do the similar thing with images, for example, removing faces, license plates, and personally identifiable text within images. The problem with that is that if you are training a machine learning model with something that isn't there and it was pre-trained on a bunch of very natural looking data, it can lead to downstream model accuracy loss. So a solution is synthetic data, and specifically synthetic PII. You can replace names with fake names, locations with fake locations. You can replace faces with fake faces and license plates with fake license plates. And therefore, you're training your model with data that's as close as possible to the original one, but while maintaining the privacy of those bits of information. And the interesting thing with these kinds of technologies is that you can still tell how well a customer service conversation went. Does an agent need training? What kind of sentiment was associated to a particular product? You can still tell that in this email, somebody's truck or somebody's car got hit by a truck. That's all very interesting contextual information that you just don't need the PII for. And one thing to keep in mind is that when you hear about how anonymization does not work and how it takes away too much information, generally that's conversations about structured data. And also referring to headlines that don't necessarily understand what anonymization means. You do have to be very careful when you're creating this to say you're de-identifying, not anonymizing. However, if you do need fully anonymized data, that's when you bring in a machine plus an expert in the loop in order to ensure that nothing can re-identify an individual. The point is that when you're dealing with unstructured data, it's an entirely new paradigm because there is so much contextual information that's really rich, and the PII is really what's toxic and what's stopping you from getting to that contextually rich information a lot of the time. And generally what's stopping people from being able to monetize their data. So, it does prevent downstream model accuracy loss in many cases if you do that synthetic PII. But another really interesting side note is that it also reduces re-identification risk, because if any PII is missed, it's very difficult to tell what the original data was from the fake data. And there's some interesting work out of the University of Toronto as well on this particular topic, particularly looking at word embeddings, but this can also apply to BERT and other language models. Mention this. Now, what about federated learning? Federated learning is very useful for maintaining input and output privacy, but not necessarily training data privacy. There's this really great work by Boynish et al. From the Vector Institute that talks about how using federated learning alone, you can still recreate a lot of the training data with a good amount of confidence. So it really needs to be used in combination with differential privacy or de-identification in order to prevent that memorization of person-identifiable information. It is very hard to tell a lot of the times what kind of privacy-enhancing technology is useful for your particular task. So we do have a privacy-enhancing technologies decision tree that you can take a look at. Happy to send a link towards to you. But really what I want to get across is for each of these privacy pillars for AI, and for dealing with fairness, for dealing with bias, for dealing with explainability, these all interact together, and they need to be a part of one system. And in that system, there needs to be accountability for the data protection regulations that are out there as well. Really hoping MLOps systems get there. I would love to take questions if anybody has any, including what kind of PII, what is more detail about what is PII, what kind of data protection regulations might apply to you. Yes?
So you talk about accountability. So given that we have on the MLOps, we have the data science, we have the machine learning engineers, and we have who has to deploy that and maintain that. How do you see the responsibility falling off? Would be someone that controls the data, responsibility on the company, or would be something that it has to be shared? And how would be your proposition and how we should handle that situation? Like responsibility and how we share that in a organization level.
Great question. So I'm going to give an example from what Twilio did when complying with the GDPR, when creating the GDPR program. And the DPO at Twilio mentioned how she put it in place. She made sure that they had buy-in from the very top, but that every single person in the organization was accountable to being GDPR compliant, to following these regulations, and to really protect the customer trust and privacy. And that has been working really fantastically for Twilio. If you have one particular part of the organization that is in charge of all of the privacy problems, they're not going to know what's happening in every corner. Everybody needs to be empowered to say something. And one of the main problems with that is there are very few tools out there to make it easy for people to, once they say something, once they realize there's a problem, how are they going to solve that problem? So developer tools are super important in order to enable the easy solution for this problem, because not everyone's an expert, right? And not everybody should be an expert, but even if they want to do the right thing, they might not have the budget or the means to do it. So something to keep in mind as new tools are being developed.
Thanks for the great presentation. I have 2 questions. The first question is, how do you make your algorithms domain specific? So, for instance, you're filtering credit card. What about, for instance, for our case, investor and treasury services, we have specific, keywords and specific, domain specific, words that needs to be de-identified. So how do you do that? And the second question is, what is the risk of a miss? So what about if you miss de-identifying a piece of information? How do you handle that?
Yeah, great questions. So how to deal with domain-specific data? Do you mean directly with how private AI deals with it, or in general, how you deal with it? In general. For domain-specific data, let's see. If you're using differential privacy, there is that positive that the rare information is not going to be memorized. So you have a higher certainty that if it is rare information, in fact, and it doesn't get repeated a lot, it won't be memorized. The question is, if you have millions of documents that you're processing, how many times does that bit of information occur, and what kind of guarantees can you make accordingly? So you do have to do a certain amount of analysis of the data in order to be able to determine how well that particular method will work for your domain. In terms of de-identification, you can train models specifically for that domain-specific data. At Private AI, we have an entire team of annotators that is really efficient in getting domain-specific data annotated and integrated into the models within a month. So those are 2 ways. And your second question, apologies. The risk of a miss. So that depends on the kind of data that you're dealing with. It depends on what other information may have been missed around it, if at all. And it depends what you were doing beforehand. If you were doing nothing beforehand, removing the information is so much better. If you were not touching the information before, and you're dealing with credit card information, for example, and you have a call transcript, and the credit card number is mentioned, but you don't have the person's name or or their mother's maiden name or any other information surrounding the credit card number, then that's still a fairly low risk, because you can't do anything with just a credit card number, right? You don't have the 3 digits, you don't have the address. If you have an entire person's information that was missed, then that depends on what kind of regulation you're trying to comply with, or what ends up happening with that data. If it's HIPAA, you have a per person fine that you have to deal with. If it's the GDPR, that's unclear. It depends what the courts decide. But really, what the courts are expecting is that you're doing the best possible. You're using the best possible systems, and you've thought about this, and you've measured the risk yourself. And they will look much more kindly on somebody who had a miss but had systems in place than somebody who was not protecting their data in the first place.
Hey, thanks for the great presentation. So you had the slide with the draft EU regulations where there were going to be like 3 different buckets of like low risk, high risk, and maximum risk, something like that. So looking at the high risk category and combining that with the idea that there's about 99.5% accuracy to these DID techniques, I think you had a slide at the beginning for that, or it might be on your website. So how do you think through situations like that, where you're in that high risk category and you're using these models for DID that are 99.5% accurate, but not like 100%? So there are a few things to unpack there. Number one, the high risk is really what the outcomes are for the individuals. So you're thinking about systems used in the administration of justice. In that case, you're likely going to be using PII. If you're thinking of recruiting or employee management systems, also you'll be using PII. So they're different problems. This one's in these particular cases,
It's very much a concern about what the ethical ramifications are, whether there's fairness integrated into the system and explainability integrated into the system. In case of in case of systems that are, for example, evaluating consumer creditworthiness, I guess the risk there would be when you're training a system with information that contains PII, but you don't, or that you remove the PII from except for the particular person that you're looking at, and then there is a miss there. This is a really good question. I think the way you have to think about it is even humans are not going to be 100% accurate. You're minimizing the risk a huge amount by removing the PII in the first place. And there's this misconception that privacy technologies can ever be perfect. They never will be, much like cybersecurity technologies. Even cryptography is not perfect, right? We have to switch cryptographic schemes every now and again, every time one breaks. So it's really about looking at the mitigation rather than whether it should be perfect or nothing.
So what if you're dealing with a very conservative kind of organization and they're thinking through that in terms of like we have to be 100% accurate? Like how would you think through and explain that and get buy-in on something like that?
Mm-hmm. Generally, if they need something to be 100% accurate, they are not creating a system at that moment. And then it's a way of weighing the risk of the benefits versus what happens if there is a small leak. And it's not just removing the personally identifiable information on its own that has to stand. They also have to have the right systems in place to prevent the misuse of the information, prevent wrong parties from getting access to it. So it's an added layer of protection rather than the only layer that somebody should be relying on, just like any cybersecurity system.
Okay, and if I can ask one more follow-up, what do you think of like k-anonymization or just techniques like that in general in terms of like bucketing, aggregation? Because I noticed that wasn't really one of the solutions that you proposed. So is there like recent research that it's not very good or it's hard to get those guarantees, or what's the thinking on that?
So, great question. Anonymization is tricky, and the reason I didn't put that up as a solution is because people misuse that term so often. There'll be companies that will claim to have anonymized data, and then, for example, one data set that was released contained the zip code of the governor of Massachusetts, and they were able to re-identify this individual. Then there's the Netflix database debacle where they were able to see the dates in which people had posted reviews on Netflix and cross-link them with IMDb. I think that in a lot of cases, companies will claim anonymization without fully understanding what is a quasi-identifier and how that can relate to individuals. And that expert in the loop that would be so crucial is missing. So anything that I put up on the slides, I like it to hold in terms of what the terminology means for the majority of organizations.
Okay, cool, thanks.
Thank you. But anonymization, so there is the HIPAA Safe Harbor has a list of personally identifiable information that you need to remove in order to be compliant with HIPAA and share data with a third party. There's been a lot of work showing that those lists of entities are not enough, but they are the only regulation, as far as I know, that has a risk threshold. So they have a 4% risk of re-identification, so 4 in 10,000 individuals, and this is something to consider when you're doing anonymization, but also something to keep in mind that when that number is affected very much by the number of people that you have in your data set. So you might pass if you have 100,000 people, but then if you keep the same subset that you're interested in, it might not pass if you have 10,000 people.
Yeah, so it sounds like you can think that you're on the right track and you've done all the anonymization right now, but then in the future it can get attacked because someone discovers a new way to do some kind of de-identification with that,
Yeah,
or re-identification
it can be
rather.
tricky.
Yeah.
So really, you have to have a lot of caution when making data sets public. But it's definitely a method to keep in mind when you're sharing data with third parties, when you're storing data internally, and anything that you could do to limit the risk of your data set is really important.
Cool. Thank you.
Thank you.
Hello.
Hello.
So you mentioned some of the incentives that companies have for anonymizing data, primarily like legal, I guess, and in some cases like business requirements maybe as well. Do you find that any companies are interested in anonymization for like moral reasons? Like, is that something that someone might try to convince someone inside their company as a reason for it, or is that just kind of not at all a thing?
That's a great question. Moral reasons. I have not come across that yet. I've come across people not wanting to de-identify data in order to train models, in order to share data, in order to get access to more data because it's a legal requirement in their contracts, in order to store data more securely. There is a layer of morality in a lot of these conversations, but it's generally the bottom line that's driving them.
Okay. And sort of quick follow-up question. So this is all very complex, like anonymizing. I didn't quite catch, like, what exactly does private eye like do in this space, and like how does it sort of plug in?
Yeah, so we're actually the best system in the world for identifying and removing person identifiable information in unstructured data, and we focus especially on text, and we can also replace the person identifiable information with fake PII, and we do this over 3 different languages and growing, and you could try our web demo if you're interested. Thanks.
Hey, so just going after the point that was made just before this, so I'm kind of curious about companies that don't actually care about this. So you had an example that was showing up where the fine was too small, or a company does not operate in the UK. So they're just like, we're not going to do it, it doesn't matter.
Yeah.
When you come across organizations like that, like how do you have that conversation? How do you make them care that AI needs to be ethical and needs to be moral, or it's just largely compliance and regulation driven based off of fines and based off of their bottom line?
If they don't care, they don't care. What might make them care is removing an entire segment of their business by threatening to delete algorithms. What might make them care is sometimes fines. But what really might make them care is taking a look at what happened to Meta's stock. They had the largest drop in stock market history this year. And that is because they lost a lot of customer trust. So there's starting to be this understanding that privacy really does affect your bottom line and really does affect trust. But then there are, of course, surveillance companies that, like Clearview AI, that can make millions of dollars because there are parties who are willing to buy their technology and they're not selling directly to consumers. There are, on the flip side, a lot of companies that are succeeding because privacy is at their core, right? So Telegram, Signal, they're competing with WhatsApp, and they would have had probably no chance had they not had privacy as a core value to their products.
Cool, thank you.
Thank you. All right, you can pass by the Private AI booth if you'd like. We are running a raffle for yoga mats if you sign up to our mailing list. So just a final point there. Thank you very much. If there are no more questions.